You guys are doing absolutely fine. This is the continuation of the JavaScript series which we have started, and today we'll be talking about the variables in JavaScript. Honestly, there are not many different types of variables, but yet we have three distinct types. Then we will talk about the types of variables, primitive variables and reference variables. We'll talk about where the variables and the objects lie. That's the stack memory, heap memory. Then we'll talk about variable hoisting. So let's talk about variables. Let me just type it down first of all. So we have so we'll be talking about the variables in JavaScript, types of variables. We'll talk about primitive and reference variables. We'll talk about stack and heap memory, and we'll talk about variable hoisting quickly. Okay, so first thing first, different types of variables. So there are three different types of variables. We have variables, we define variables using let, we define variables using const, and we define variable using var. So you might have seen variables defined using var a lot. Let and const were as a part of ES6, ECMAScript 2016. So it is a part of ES6 syntax, whereas var has been there from from the beginning of JavaScript. So all this, using all these three types, you basically can define a variable in JavaScript with a value. For example, I can do var x is equals to 1. I can do let y is equals to, maybe I will just write my name, let y is equals to, and let z is equals to, yeah. So okay, sorry, where let and const, and we can, so I will just show you by logging x comma y comma z. That's fine. So these are the three different types of variables, where, let, and const. So the difference between these three types, I will just quickly explain. Whenever you are declaring a variable using where is actually not recommended to be used, and I will just quickly tell you the reason why we should not be using where. The main reason of why to not use the where also lies in the variable hoisting, how the variables are hoisted. So where any variable that is declared using where, you can redeclare it. For example, I can again do where x is equals to maybe something, and if I run this, so I will get something Priyanka and Viraj. So my name is lost somewhere. So the problem is you are redeclaring the variable again. See, redefining is not a problem. If I can do y is equals to x, some random value, and I can do this. If I again run, so I will see I'm updating my value which was assigned to y, but I am redeclaring the variable x. So the problem of redeclaring is that if you're having a big function, a function with too many lines of codes, and in the beginning of the function, if you have declared a variable using var, and after a particular point of time, you may again try to redeclare it. XYZ, you should not be defining, you should not be having variable names as XYZ. We should be having meaningful names. But it may happen that you again try to redeclare a variable inside the function, in some other part of the function, you again try to redeclare the variable. So you are accidentally overwriting the existing value. Whereas overwriting the existing value is not problem, but you are redeclaring the variable, which is not a good practice at all. You may lose some of your credentials. Suppose you have kept some of your credentials in a variable using, and you have declared that variable using var, and you suppose after after certain lines of code inside a function, you forget that you already had declared that variable and you redeclare it. So you accidentally you lose the value of that variable. So the problem is this is something which can create a lot of bugs, and that's one reason why it's highly not recommended to use var inside your code. The benefit of let is that whenever you are declaring a variable using let, what happens is you can't redeclare it. Like for example, I can't just do let y is equals to something, and your compiler immediately will give you an error, cannot redeclare block scope variable y. So you will immediately get an error. Even if you try to run the code, it's gonna throw an error. So identifier y has already been declared, so your code becomes directly bug free, and this using let reduces your chances of having bugs in your code. Next is the const. So whenever you are declaring a variable using consts are basically for constants. If you want something like, for example, some keys, credentials, if you want to store some credentials, it's better to use const, because when you're using const, you can't redefine that variable. So I can't just do z is equals to something. So you see, it is not giving me an error, but if you try to run the code again, assignment to a constant variable, so you will get an error saying that assignment to a constant variable. That means you can't change the value of a constant variable. You can change the value of let, but you can't change the value of a constant variable, because by the name itself it says it's a constant is something that should not be changed. This is one reason why so these are the three different types of variables: var, let, and const. And this is one reason why you should not be using var, because var is something which can be redeclared. Not a problem with redefining, but a var is something that a variable declared with var can be redeclared. That's a problem. The another thing with vars is that a variable that is declared with var is a function scope variable. What is meant by function scope variable? So if I'm using function, so if I'm writing a function test, some random function, okay, and I'm doing var suppose x is equals to 1, and suppose x is equals to 1, what happens is that where the variables which are declared using var, the variable becomes a function scope variable, whereas the variables declared using let and const, they are block scope variables. For example, if I am having a for loop and if I am using, okay, let me remove var from here. I guess this is the better example. If I'm doing var, so you guys might be aware about the syntax of for loop, the conditional syntaxes and the syntax of for loop and looping syntaxes and all. For loop is basically, so if for anyone who is not aware, I'll just quickly tell what is a for loop. A for loop is something using which you can iterate over some values. For example, if you're having an array of some values, you can just use a for loop. A for loop will basically iterate over the entire values of an array. So I will not be going deep into how for loop works and this and that, but it's a generally I've just explained. So you can just iterate over the values, loop over the values. So if I'm doing x is equals to 1 and I'm saying x is smaller than 10, so and x plus plus. So what I mean over here is like you start x from 1, go from 1 to maybe x, I will start it from 0 itself, go from 0 till 10, and after every iteration what you have to do is you have to after every iteration increment the value by 1. Okay, simple. So I'm saying console.log, and I'm saying I'm printing the value of x. That's fine. And I run this code. So expected is it will print from 0 till 9 because 9 is smaller than 10. Then okay, I have to call this function also, right, from somewhere. Yes. Okay. Console.log x. So expected is it is going to print from x is equals to 0 till 9. Okay, from 0 till 9, because after 9 the value becomes 10. Then again it is going to check the condition, is 10 smaller than 10, false. Since it is false, it will come out of this loop and it will exit the code. So it is printing from 0 till 9. Till now no problems at all. But what if I am using a set timeout function or a set interval function? So we'll come on what is set timeout and set interval, but I have discussed more on set timeouts, set intervals in my first video where I explained you guys about the event loop of JavaScript and how the event loop works and all. So set timeout is something which is used for it is a timeout function. That means we provide a delay and we say that till this particular time has been passed, you please do not call this function. So call this function only after this certain interval of, not interval, after a specific amount of time. So for example, if I'm saying set timeout accepts a function. Set timeout accepts a function, and set timeout basically accepts two parameters. It accepts a function which we want to call after a specific timeout. So I'll say after 1 second. I mean, it's specified in milliseconds, so 1000 milliseconds is 1 second. So I'm just saying here, after 1000 milliseconds, call this particular function. And inside this function, I'm saying console.log x. So in JavaScript, functions are first class citizens. What do we mean by first class citizens? First class citizens means a function can be passed as an argument inside another function. A function can be returned from a function. So everything basically revolves around function in JavaScript. Okay, but the topic of today's video is not about working on functions, but since I want to explain about the drawbacks of a variable declared using var, I am just giving you an overview of functions and why using variables with var causes problem. So what happens over here is that in every iteration I'm setting a timeout. I'm seeing that call this function, like console the value of x after 1000 milliseconds. So for when the value of x is 0, I'm calling this set timeout and I'm saying that okay, print the value of 0 after 1000 milliseconds. Then print the value of after this, in the second iteration, when the x is equals to 1, I'm saying print the value of x as 1 after 1000 milliseconds, that is after 1 second. So the expectation is that it should print 0 1 2 3 4 5 6 7 8 9, but after 1 second, right? So first 0 will be printed after 1 second, then 1 will be printed after 1 second, then 2, then 3, then 4 till 9. Correct? So let's try to run this code. Okay, you see it's printed, it has printed 10 10 10 10 10 and 10. That's a problem, right? Because it did not print 0 1 2 3 4 5 6 7 8 9, instead it just printed 10. This is because this variable x, which is declared using var, it becomes the function scope variable. See, set timeout is called after 1000 milliseconds, that is after 1 second. Before the set timeout, before the first set timeout is called, this function execution has already been completed. Because this is an asynchronous piece of code. Set timeout, we have discussed this in the previous lecture where we discussed about the event loop. This is a timer function. This timer functions, this basically are asynchronous functions. That means our code is not going to wait till 1 second is completed. It is just going to queue this in the timer's phase, queue this function in the timer's phase, and it will proceed to the next value. So till the time our first callback is called for x is equals to 0, our function has already been executed. So what happens is that since our function has already been executed, what is the last value of var? The last value of var is 10. What happens is that whenever you are declaring a variable using var, it becomes function scoped. So the last value of var is the last value of x is 10, and since this is a function scope variable, our set timeout is going to see the value of x is equals to 10 at the end when our first timer is going to execute. After 1 second, when our first timer is going to execute, understand this function call has already been completed. The value of x is 10, and since this x is a function scope variable, what is the last value of x the timeout is going to see when it is going to execute? The timeout is going to see the value of x as 10, because x is a function scope because the scope of x is functional scope, since x is declared using var. So that is the reason why we see 10 over here. Now if I redeclare this with let, what happens is that let is a block scope variable. By block scope variable, we mean for every iteration, this is a block. Anything that is within a curly brace is called as a block in JavaScript. So let me just quickly execute this function. So you see it printed 0 1 2 3 4 5 6 7 8 9, because you see this is a block. Whenever I have declared x as let, so I'm declaring x using the let, so I'm saying let x is equals to 0, so x becomes block scope. So for every iteration, so like first iteration when x is equals to 0, for first iteration, for first block, the value of x becomes equals to 0. So what happens is that this value of x basically gets preserved for this block. Then the value of x becomes 1. So for the first set timeout, the value of x will be preserved as 1. Then for the second timeout, the value of x will be preserved as, for the first timeout, the value of x will be preserved as 0. For the second timeout, like in the second iteration, the value of x will be preserved as 1, because x is a block scope variable. Now what actually internally happens is that a closure is created around x, around the value x. So because x is equals to 1, and because x is a block scope variable, our first set timeout, which is having x is equals to 0, it is going to see the value of x is equals to 0, because a new x will be created for the second block, a new x will be created for the third block in the sense third iteration, because x is a block scope variable. And this is like very important, because normally what you are going to do is in JavaScript later on, you are going to use async function calls inside for loops as well, and it's very important that you use let, because using var, because if you use var inside asynchronous code and inside loops, you can basically pass wrong value of variables inside the asynchronous block of code. So that's the problem. So it's very important to use let, especially with asynchronous programming, else wrong closures will be created. We'll work around closures, and we'll talk more on closures, what are closures and all, but it was very important um, to let you guys know that you know why we should not be using where over here. Since we have, I understand we have not discussed about closures, but for giving this context, it was very essential to tell about closures and all. So okay, so this is about let constant where. Um, let's talk about the next stuff, which is hoisting. So what is variable hoisting? So we discussed about three different types of variables: let, constant, where. Now let's talk about hoisting. So what happens is that if I'm having a variable, if I'm saying let x is equals to 1, so JavaScript hoisting in terms of JavaScript means that the declaration of this variable is brought to the top of the function. Now let me write a function test, and we'll say let x is equals to 1. And what happens is that in the call stack, so we also have a proper video on the call stack, how call stack executes. So what happens is that for every function which gets executed, an execution context is created inside the call stack. So for this function, its own execution context is created inside the call stack. So what happens is that in its execution context inside the call stack, the declaration of the variables is brought to the top. By what does that mean is that, for example, if I am having let x is equals to 1, and if there are some 50 lines of code over here, 50 lines of code, and can I do console.log x over here? Will it work? But x is declared over here, so it should say x is undefined, or the variable x is not declared, or something. Let us run this code and see what happens, what error it basically gives. Oh sorry, I have to call test, I always forget. It should give some error for sure, but it is saying cannot access x before initialization. What does this error mean? When I'm saying console.log x over here, but x is defined over here, so ideally our compiler should say that x is undefined, or there is no such variable or as x, right? But it is saying cannot access x before initialization. That means our compiler knows at this point of time that there is a variable called as x inside this function, but the value, but it is not defined over here, but x is defined over here. So the initialization of x is over here, but I'm trying to access this before initialization. So that is the reason it is giving reference error, cannot access x before initialization. That means our compiler knows that there is a variable named x inside this function, but it is not yet declared. Sorry, but it is not yet initialized. But compiler knows that there is a variable x. That means even before this function call, even before this function is being called, our JavaScript compiler internally is doing something like this. Maybe not even undefined, the value is not even undefined. It is something called as not initialized or something. Initialized, sorry for the spelling. But the thing is, when JavaScript comes into this function, it sees all the variable declaration inside this function. When this function is loaded into the call stack, an execution context is created for this function. Inside that execution context, what it does is it scans the entire function, and it checks which all variables have been declared inside the function. And what JavaScript does is it automatically redeclares those variables to the top of its execution context, but a variable with let is marked as not initialized, but it is declared at the top. So even before console.log, JavaScript has done this, but it has kept its value as not initialized. So when my compiler comes over here, my compiler knows that there is a variable called as x, but it is not initialized as of now, and that is why it gives this error. But what if I do where x is equals to 1? Will this give an error? Let's see. Okay, undefined. So that means what JavaScript did over here is JavaScript for a variables declared with where, JavaScript did something like this, where x is equals to undefined. In terms of let, what JavaScript did was JavaScript marked the variable as not initialized. So if you're trying to access the variable, let variable before initialization, before initialization, if you are trying to access the variables declared with let, not where, let, JavaScript upfrontly will give you an error saying that this has not been initialized. You first initialize it, then use it. So this is kind of an error handling which the JavaScript engineers did in the ES6. Prior to ES6, there was no let, there was no const, there was only where. So there were chances of introducing bugs in the code. Sometimes it happens that you declare a variable and you try to use it before its declaration. Then JavaScript should give you error, but in case of where, JavaScript is not giving you error, it is just saying undefined. So this is something which can cause bugs in your code. And all this bug fixes, error handling was done by JavaScript in the ES6 standards. Like when the ES6 standards were launched, JavaScript did all this bug fixing and all. Since it's there is, and obviously it justifies, why, because JavaScript is not strongly typed as Java or other object-oriented programming languages. JavaScript is not purely object-oriented programming language. It's kind of, you can say it's not even procedural programming language. It's functional it's we say this in the functional category. Everything revolves around functions and all. So this is what hoisting is. Now same with const. If I'm doing const and if I'm trying to access const before initialization, it will give me an error saying that cannot access x before initialization because it is const. So all the three types of variables, let, where and const, they are hoisted. All the three types of variables, let, const and where, are hoisted by the JavaScript. Where does the hoisting happens? Hoisting happens in the execution context when the function is loaded on the call stack. At that moment, JavaScript basically scans the entire function, checks which type of variables have been declared inside the function, and brings the declarations of the variables to the top. Whatever you can have, let y is equals to something, you can have where, let, const inside the function. At any part inside the function you can have this declaration, but when this function gets loaded into the call stack, an execution context is created and the declarations of these variables are brought to the top of the function scope, to the execution context. But variables with let and const are marked as not initialized. It will give you an error if you try to access it before initialization. And the variables with where are marked as undefined. It's very important. So this is one reason why you should not be using where if you want to avoid bugs in your codes. In your code. So avoid using where, use let and const. It's more safer, more bug free, and more error free. So this is what we have discussed. This is done. Types of variables is done. Variable hoisting, actually this should be over here, because it goes with the drawbacks of using where. This is also done. Now let's talk about primitive and reference variable. So what are primitive and reference variables? So primitive variables, by the name says, these are the variables which are not complex, simple variables, like the variables which your CPU is going to understand. That by what does that mean is, for example, if I'm doing let x is equals to 1 2 3 4 maybe, Now this is a number, right? So we all know that in the low level language, what happens on the low level inside the CPU, what happens is that every number, so CPU will not understand what is 1 2 3 4. CPU is just going to understand your microprocessor, not CPU. Basically CPU is a collection of multiple things, but your microprocessor, which is the heart of your CPU, your microprocessor is going to just understand zeros and ones. It is not going to it is just going to understand zeros and one. So because it just understand binary bits, zeros and ones. It's not going to understand anything apart from that. So this primitive variables like this 1 2 3 4, this is internally converted into zeros and ones. So it's internally converted into a binary number with zeros and ones, and your CPU is going to do operation on that binary number. CPU is not directly going to do operation on 1 2 3 4. It is going to do operation on zeros and ones. I don't know how many of you guys know, but like most of the people know now that your microprocessor mostly does only arithmetic operation. There is an ALU unit inside the microprocessor, arithmetic logic unit, which is responsible for doing the logical operations, which is responsible for doing the addition, subtraction, multiplication, division. So this is done by the arithmetic logic unit. What does that unit do? It takes one value in binary, it takes another values in binary, and it will do some operations, right? It will do addition operation. We all know how addition, like how binary bits are added, how binary bits are subtracted, multiplied, divided. Multiplication and division is quite easy in binary. It is just addition and subtraction itself, nothing fancy. There are XOR operations, there are bit shifting operations and all, but the whole context which I'm trying to say is that everything happens in zeros and ones. So any variable which is easy to declare in zeros and ones, we can say that that variable is a primitive variable. 1 2 3 4 can be easily defined in zeros and ones. Like if I'm saying one, how one can be declared. So for 8-bit or for a 1 byte, if I'm saying that normally what happens is integer is of 2 bytes and the long integer is of 4 bytes. So when I'm saying 2 bytes, it is 1 byte is of 8 bits, so 0 0 0 0 and 1. So this is 1 byte, this is second byte, so this is second byte, this is the first byte, this is the second byte, 8 bits, and this is 1. So 2 raised to 0 is 1. So we, since this is just zeros and ones, we can get its actual value using 2 raised to the power and all. So that's we are not going to go into that zone, but what I want to say is that numbers can be easily represented into binary bits, in a binary format. Then characters can be easily represented into binary formats. We have because we have ASCII value for every character. Strings can be easily represented into binary. So your CPU, your microprocessor can easily understand binary bits. So any variable which can be easily declared into zeros and ones, we can call that way. Those variables are primitive variables. Now what are non-primitive? Non-primitive variables are those which cannot be declared, using zeros and ones, which you can't just simply. So if I'm having const x is equals to an object, maybe name is equals to this, how are you going to declare this in zeros and ones? You can't just declare this in zeros and ones. Or suppose if I'm having const y is equals to 1 2 3 4, how are you going to declare this in zeros and ones? You can't. So what happens is that this is a data structure. This is just the representation of data in a different format. So why do we represent data in a different format? Because we want easy access, like we want to keep group of data together. Now this is an array, so there is a reason why we should use array. There is a reason why we should use object if you want to keep related data together, that is data structure. It just makes accessing the data easier, complex data. um, so so basically over here what will happen is that one will be stored somewhere, two will be stored somewhere, three will be stored somewhere, and four will be stored somewhere else. But what I basically want to say is that this is not we will talk more about how this is stored in your memory. But what I want to say is that um, this is an array, and this is not primitive because we can't just directly convert this into zeros and ones. So our CPU, our microprocessor will never understand how to represent this particular data in our memory. And the another thing is, since this is an array, our microprocessor only does arithmetic and logic operations. It will only do addition, or it will only do subtraction, or bit manipulation, shifting of bit, XOR operation. But it does not know what to do with this kind of data. You can't just do this plus this plus this. You can't do this plus this. It doesn't make sense what to do with this. Our CPU, our microprocessors, just do basic math operations, nothing else. So so what happens is, so this kind of data, this array, this kind of data is stored in your memory somewhere, because at the end we need everything to be stored in the memory. And by memory I mean the random access memory. Random access memory, by the way, is RAM. So we basically store this in RAM somewhere. This one is stored somewhere in some memory location, 2 is stored somewhere in some memory location, 3 is stored somewhere in some other memory location, and 4 will be stored somewhere in some other memory location. And our Y is basically, in case of arrays I'm just talking now, not in case of other data structures, our Y is basically going to hold the first memory address, or Y is basically going to hold the reference of this array inside the memory. Reference in the sense, so our Y is basically going to hold a memory address, so that when I access that particular memory address, I will get this entire array. In short, our X is basically our X is a variable such that it is going to hold a memory address, such that if I access that memory address, I will get this entire object. These are the reference variables, because it does not have its value of its own. This Y is not having its value of its own. It is a reference object. Reference in the sense I am referring to some other object. Y is referring to this array. X is referring to this object. So these are the reference variable. Any variable which is complex, any data structure which is complex, whether it is array, it is objects, whether it is maps, whether it is sets, whether it is linked list, graphs, trees, anything, those are being referred. Those are being a variable that holds the reference of these data structures. That variable is called as the reference variable. Now this values, obviously we have to store this value somewhere, right? This is just the representation of the data, but internally our RAM is having something called as a heap memory. A heap memory is ununiformed distribution of memory. So heap memory is basically a piece of memory which is very random, which is not uniformly distributed, which is expandable as per the needs, and but it resides inside the RAM itself. So this is inside your RAM itself. If your RAM is of 4 GB, 8 GB, then heap memory will be over there. Okay, and all these variables which you want to use in your program, whenever you declare these variables are inside your heap memory. And when these variables go inside your heap memory, suppose if you are using a function, when that function is bought on the call stack, that is the moment of time when this variables gets initialized, and when in the heap memory you basically create those variables inside a function. If you are doing const y is equals to 1 2 3 4, that is the moment when in your heap memory you will give memory addresses to all these variables. But yeah, all these variables basically lie inside your heap memory. So what happens is that inside your heap memory, if I give you a general idea of what happens is, inside your heap memory, if you are having some memory address 0 1 0 0, so let's keep it simple. So inside a function, if I'm doing const y is equals to 1 2 3 4, what happens at that moment of time when this function is bought on the call stack, an execution context for that function is created, and when your compiler hits this line, this is a variable declaration. JavaScript will scan for all the variable declarations initially inside the function. So when it comes over here, when it basically executes this line of code, const y is equals to 1 2 3 4, what happens is inside your heap memory, for one memory location, I will be assigning the value 1. For another memory location, I will be assigning the value 2. For third memory location, I will assign the value 3. For fourth memory location, I will assign the value 4. And y is basically going to get x is equals to, like, y is basically going to get this memory location, and y is basically gonna get this memory location. So what is y over here? Y is referencing to this memory location, but does y have its value of its own? No, y does not have its value of its own. Y is just referencing to this memory location. So that is why this is a reference variable and this is not a primitive variable. But when I do const, but when I do let let z is equals to 1, my z is actually holding 0001. Okay, it is not holding reference to some other memory location, but it is actually holding 0001. So this is the reference variable and this is the primitive variable. Understood? Why does y gets value x0001? Because this is the starting point of an array. If I want the value 2, what I will just do is I will just do this plus 1, which will basically give me 2. So I can just, so when I'm doing y of 1, what happens is that I take the base address of y, which is this, and I add 1 into it, plus 1. So I'm adding 1 to the existing memory location, so it becomes 2. And what is at x0002? Which is 2. So y of 1 becomes nothing but 2. Okay. This is internally how it works. But what I explained was the high level thing. Okay. So this is about primitive and reference variables. Simple primitive variables are any variables which hold the actual value and not the reference to some other value. Primitive variable holding the actual value. When I'm saying z equals to 1, it is actually holding 0001. Same goes with characters, because characters are basically internally converted into ASCII values. Characters have their ASCII values. Same goes with string, because string is nothing but collection of characters. It's the combination of characters. So strings can also be represented into binary bits. So any variable which has its own value, which can be defined into zeros and which can be expressed into zeros and ones, that variable we can say is a primitive variable having the value of its own. Well, reference variable does not have it does not have value of its own. Instead, y is pointing to some other memory location which is holding some other value, a reference variable. Same goes with x also. Nothing fancy. X is basically pointing to something else. Now JavaScript has this, but other programming languages uh, don't have objects like this. They don't have JSON objects like this. Like if you talk in terms of Java, if you want to have represent anything like this in Java, you need to create another class which will be having values like this. It's kind of more predictable language, what can be done and what cannot be done. You can't just randomly do anything in Java because it is strongly tight. But we are not talking about Java over here, we are talking about JavaScript. So okay, this is what a primitive and reference variable is. I will mark it as done. What is stack and heap memory? So we discussed about heap memory, right? What goes into heap memory. But when I do let z is equals to so any reference variable, so if I'm creating any complex objects like arrays, like JSON objects, like linked list, or if I create a tree, if I create a map, if I create a set, everything is going to go into heap memory. Then what is stack memory? So stack memory is basically nothing but, so inside stack we know that whenever I want to execute a function, JavaScript is going to load that function inside stack, and an execution context is created inside the stack. A stack is a data structure, last in first out. Okay, so it's basically important to use stack over here because we need to know which was the last function or which was the last line we executed, you know. So that's the reason why we use stack over here, why functions are executed inside the stack. So we know one thing, that a function, when a function has to be executed, that function is bought on the stack, an execution context is created in the stack, and when the function is bought on the stack, JavaScript basically will scan the entire function. It will scan for all the variables. If it comes over this a complex variables or reference variables or arrays or objects or linked list or anything, it will create this inside the heap memory. It will create this entire object, entire array inside your heap memory, and your y will be on the stack. But what is your y going to hold? Your y is going to hold the reference to some memory, so some memory location. It is why your y is basically going to hold a reference to some memory location which is in the heap memory, correct? So your y is basically going to hold a reference to it's basically going to hold a reference of some memory location. Where is this memory location? Inside your heap memory. Same goes with x if it's a JSON object, same goes with linked list. But what if inside your function you have a primitive variable, let z is equals to this, let z is equals to 1. So this one is not, so this one also has to go into some memory location, right? It has to go into some memory location, maybe x0011 or something, but this memory location is in your stack itself. This memory location is not in your heap, this is in your stack. Only certain things go into your heap memories, not everything. Especially, you know, when you're doing closures, what happens is that if you're creating a closure around this, then this value gets moved from your stack to heap. But this is something which we will discuss later on. But what I just want to say is that this is your stack memory. Primitive variables usually are kept on the stack memory because those primitive variables are only needed till the function is getting executed, till the execution context of the function is present on the stack. Once the function gets executed, once your function gets executed, the execution context of that function is removed, and internally all the variables which were declared in that function gets removed from the stack. But one question should come in your mind. So if in a function, if I'm doing const y is equals to 1 2 3 4, if in a function, if I'm doing const y is equals to 1 2 3 4, this 1 2 3 4 will be created only when the function is loaded in the call stack. That means the execution context of that function is created in the call stack, and when the compiler hits this line inside your function, this line, then only 1 2 3 4 this entire array will be created inside your heap memory. And the first memory location, now I'm talking in terms only of array, the first memory location will be given to y. So y is basically holding a reference to this memory location which is in the heap memory. So when the function is entirely executed, okay, the function is the execution of that function is completed, we remove that function from the call stack. The execution context is removed from the call stack. So any primitive variables will be removed because these primitive variables were present in the stack memory. So this is removed, understood. But what about, so this y also will be removed because y was present for that function, y was declared in that function. Since the function's execution context is removed, this y also should be removed, right? But if y is removed, what about all this variable, what about all this memory addresses which were created in the heap memory for this array? What will happen to this memory addresses, the memory addresses which were holding 1 2 3 4 inside your heap memory? So what happens is that this memory address will remain in your heap memory. So even after the execution context is removed, now initially when the execution context of that particular function was present in the call stack, y was holding this memory address. But now the execution context is removed, so y is also removed. Now there is nothing in the call stack which is holding this memory address x0001. There is nothing in the call stack which is basically holding this memory address. Since there is nothing in the call stack which is holding this first memory address, because in arrays we always give the first memory address to the reference variable. Now if this variable is holding this array y is equals to 1 2 3 4, the memory address of the first value x, the memory address x0001 of the first value will be given to the y as reference. JSON objects behave in different way. In linked list we give the reference to the reference of the first value, first node of the linked list. In trees we give reference of the root node, you know. But what if there is nothing in the call stack which is referencing to this first value? Now what in this case? So in this case what happens is that all these values in the heap memory, they get eligible for garbage collection. So primitive variables will be removed from the call stack immediately because they lie on the call stack in the stack memory, the primitive variables. So the execution context is removed, the primitive variables are removed, they're lost forever. But the memory addresses in the heap memory, the values in the heap memory, they are not removed immediately. Instead they are removed after some amount of time. They become eligible for garbage collection would be a suitable word to use over here. Garbage collector will basically remove them since there is nothing in the call stack which is holding this first memory address, or there is nothing in the call stack which is referencing to this memory addresses now. So if you want something to be present, if you want your values to be present in the heap memory, make sure there is a variable in the call stack which is referencing to those values. In case of asynchronous operations, call stack becomes empty, but your callbacks which are queued in the event queue, your callbacks which are queued for set timeout, set interval, or input output operation, whatever callbacks are queued, if those callbacks are referencing to any of the values inside your heap memory, then also the heap memory will not be eligible for garbage collection. Only when there is nothing in the callbacks or in the call stack referencing to this memory addresses in the heap memory, then only this values in the heap memory becomes eligible for garbage collection. I hope you guys understood. This is one thing you should understand. There should be something in your call stack or in your callbacks to reference to this memory addresses. There should be something which should reference to this memory address. If there is nothing in your code, if there is nothing in the call stack, or if there is nothing in your event queue which is referencing to this memory addresses, they become eligible for garbage collection. So this is what heap memory is, and this is what heap memory and stack memory is in short. And yeah, so it was quite a lengthy video, but I hope I covered everything about the variables, let const var, which one to use, which one not to use. The hoisting, always understand for hoisting, for variable hoisting, all the three types of variables are hoisted, but how are they hoisted matters. Variables with var are marked as undefined, which can cause bugs. Variables with let and const are marked as not initialized. Functions are also hoisted, but we'll cover that later on. Then we came to primitive and reference variable. Very easy to understand. Anything that can be represented into zeros and ones, you can say that it's a primitive variable. You know, false and true can also be represented into zeros and one. False is 0, true is 1. Numbers can be represented into zeros and 1. Negative numbers can be represented into zeros and ones. Then characters, strings, they can be represented into zeros and ones. Okay, simple. Reference is nothing but a reference variable don't have their own values. In terms of C++, we used to call them pointers. In terms of Java or JavaScript, we call them reference variable. They don't have their own value. They're referencing to some memory location inside the heap memory. So these are the reference variables. Any complex object reference, they are the, you know, if you're doing const y is equals to 1 2 3 4, y is basically a reference variable. It is referencing to this value of your object. It does not have its own value. So these are the reference variable. Then we discussed about the stack memory and the heap memory. What is a stack memory? What is a heap memory? And which variables are stored in the stack memory, which variables are stored in the heap memory. So we discussed about all these things. So I hope you guys liked this video. I know it was a lengthy video. It was I tried to convey as much information as possible from my end, and I'm extremely sorry if this video had gone a little boring, because I know it was like too much information, but I hope you guys liked it. So thank you so much. We'll come up with some next video later. Thank you so much. Bye.